Hello, sixth graders. Welcome to your video lesson on fractions and decimals. 3 learning targets, kind of a lot packed into one here. I can write fractions as decimals, I can write mixed numbers as decimals, and I can write decimals as fractions. So going back and forth, make sure you stop and think about what you already know, and good luck. So stopping to think, what do you know about our number system? What is our number system based on? And it might help you to think about place value. So it's always good to think about, what do I already know? Because that propels you to what you don't know yet. So hopefully you're thinking, what do I know about fractions, decimals, and mixed numbers? Well, what you might remember is that our decimal system is based off of powers of 10. You learned about this in science when you were working with the metric system. We learned about this when we did place value. You know this. And what we need to think about is, how will this help us when converting fractions and decimals to show that they're equivalent numbers? So this whole kind of unit is talking about numbers that are the same but can be represented differently. So remember what you know about place value, and here we're looking at, we have the tenths place, the hundredths place, and the thousandths place. And how might that help us when we're talking about fractions, which remember are, you write a part out of a whole. If I say I eat 1/2 of a pizza, that might be the same as me eating 5 out of 10 pieces of a pizza. And then how would I read that so that I could write it as a decimal? Awesome thing about math and English language is that we really have a lot of language that helps us with writing what we read, okay, using place value. So when I read the word 7/10 as a fraction, I can write that as 7/10. That means something was in 10 pieces and I have 7 of them. When I read that tenths, thinking about decimals, I know that's the place directly behind the decimal in the tenths, and I have 7 of the tenths. So I'm just writing what I read. So maybe you're ready to try the next two. 32 hundredths, I know that's 32 hundredths as a fraction. It'll be right on top of the other. I just did a diagonal that time. Or 32, notice I'm ending in the place it's been written. 32 ending in the hundredths. Then lastly, 265 thousandths. Then I can write that as 265, knowing it should end in the thousandths. So again, using that place value. So it's kind of quick and easy little tip here. If the denominator of a fraction is 10, 100, 1,000, or a higher power of 10, 10,000, so on, you can convert using mental math using that place value chart. So if I have a decimal, or I read it, if I read this decimal as 25 hundredths, I know I can write it over 100. So not always are questions readily available in the tenths, hundredths, or thousandths, so sometimes we might have to convert them to the tenths, hundredths, or thousandths. So what we would do is change our denominator. If we change our denominator to keep things equivalent, which is the goal, is we would then multiply the numerator by that same number. So we're looking for a common number that we can multiply by. And then we would just simply write that as a decimal using place value. So for example, looking at 7/20ths here, what I know is that 20 is a factor of 100. The meaning 100 is a multiple of it. So what I can do is I say, okay, well, what number times 20 gets me to have 100? And whatever I do to the top, I have to do the bottom, because the goal here is that I'm keeping everything equivalent. These are the same number represented differently. So I know that 20 times 5 gives me 100. So to again keep it equivalent, I have to multiply my numerator by 5. 7 times 5 is 35. So 7/20ths is the same as 35 hundredths. Then remember, I wanted to write it as a decimal. So then I read that 35 hundredths, that's the same as 35 hundredths. Same thing here. This one looks a little bit different because this is a whole number. Okay, so I know that this is a whole number, and that comes before my decimal. So I'm really looking at the fraction represents a part of a whole. So I have to figure out what that is behind the decimal. So I can leave the 5 alone. Same thing here. I know 3/4. I know 4 is a factor of 100. So if I were to change this and multiply it by 25, it would be out of 100. Whatever I do to the bottom, I have to do the top to keep things equivalent. So 3 times 25 is 75. So 3/4 and 75 hundredths are equivalent. Therefore, 5 3/4 is the same as 5 75/100. So down here, there are a few for you to try. If you're feeling confident, go for it, and then come back and check in. So when I read this one's already a tenths, right? 3/10. When I think about place value, I can just simply write 3 in the tenths place. Some of you might change it to 30/100. Remember, those are equivalent. That 0 at the end didn't matter. So here I have 3/25, and I look at it and I think, well, is that a factor of 100? Yes, I can change it by a multiple, 4 here. Same top and bottom. A lot of kids sometimes forget the top, and then it wouldn't be equivalent. So then I would get 12/100, and remember the goal is to change it to a decimal, so I read it 12/100, so that means that 12 to the 100ths place. Last one, we have 6 1/2, and so I know that that 6 is a whole number, and I just need to change what's to the right, the part of a number. I know that 1/2 is 2 is a factor of 10, so I can multiply both these by 5. I know that this is 5/10, which I can write as then 6 5/10. Remember that decimal is read as end. All right, good. So what can I do if I cannot convert my fraction easily to be a denominator of 10, 100, or 1,000? So then what we have to do is we have to use some division. So any fraction can be written as a decimal, any fraction, okay? To do this, what we need to do is divide by our numerator by our denominator. You've done this before, and so we are going to do it again and be awesome. You might need to add some a decimal and zeros to give yourself more places to work with, just like you always do when you divide. And the division ends when there's a remainder of 0. So sometimes they'll keep going, or it might be going into a couple places. So remember that when you're dividing, it looks like this, right? Numerator over denominator is a fraction. That's the same as numerator divided by denominator. Your numerator is what's on the inside. You're wondering how many times does my denominator go in? So let's try these. We're doing 3 divided by 8. What portion of 8 fits into 3? We know it's less than 1 whole. So we put our decimal in right behind the number. 8 goes into 3 0 times, but it goes into 30 3 times for 24 with 6 left over. Bring down another 0 because we're not to a remainder. 8 goes into 60 7 times for 56 with 4 left over. Gotta keep going. 8 goes into 40 5 times exactly. I have a remainder of 0. So I am done, and 3/8 is the same as 375 thousandths. See if you're ready to try on your own. If not, stick with me. 1/40th. I know that's not very much, so estimating helps me. 1 is going to be a tiny bit of 40, because I know 1 out of 1/10 is 1/10. So it's going to be less than that. 40 does not go into 1. 40 does not go into 10. So notice you might have a 0 there also. So I add another one. 40 goes into 100 2 times for 80. 20 left over. Bring down another 0. I know that 40 goes into there 5 times, because 4 times 5 is 20. And that is 0 remainder. So 1/40th is the same as 25 thousandths. All right, last one. Notice we have a 7, a whole number, 7 and some. So 7 is my whole number. So I know right away that this is going to be 7 point something, 7 and a fraction. So I really just need to divide my 1 divided by 8, putting my decimal in. And if I want to, I could just, so I don't forget, put the 7 there right away. So I know that it doesn't go into 1, so that's a 0, but our 7 whole number is there. 8 goes into 10 1 time for 8 with 2 left over. 8 goes into 20 2 times for 16, 4 left over. And 8 goes into 40 5 times with none left over. Remainder 0. I've completed it. 7 1/8 is equal to 7 125 thousandths. A little bit of vocabulary for you here. A terminating decimal versus a repeating decimal. Terminating decimal, if you think about the terminator, this has a finite number of digits. So this means that it's going to stop. So then the number stops or it terminates. For a repeating decimal, that means it repeats. So the digits continue in a certain pattern. And what we do if the digits continue in a certain pattern, and we learned about this before, is we're going to use that bar notation. And that just shows that something repeats indefinitely. So here are some common uses of the bar notation. Notice in this last one, the 3 does not repeat, so the bar notation is not over the 3. It's only over the digits that do repeat. So how are we going to deal with that? Well, similarly, we're still going to divide. So we're still going to divide our numerator by our denominator, filling in a decimal. So we know that 7, notice if these are all decimals without a whole number, they should be less than 1 because they represent a part of a whole, a part of one whole. 9 does not go into 7, but it goes into 70, 7 times for 63, with 7 left over. Then we notice again, we're getting 70. Goes in there 7 times. And we're going to keep getting a remainder of 7. So we don't write remainder 7. What we say is that we know 7/9 is the same as 7/10 repeating. Could have also written 77/100 repeating, and that would have been the same. Next one, 3/11. So we do 3 divided by 11. 11 does not go into 3. It goes into 30 twice for 22. 8 left over. 11 goes into 80 7 times for 77. 3 left over. Now notice I got that 30 again. We know it goes in there twice for 22. We're going to get a remainder of 8 again. Goes in there 7 times. So we can see now that 3/11 is the same as 27/100 repeating. You could write it like that with that bar notation, or simply just write to those when those first ones repeat with the bar notation right over that. Okay, so again, a mixed number, same thing. We know this is going to be 4 and something, so we just need to worry about our fraction part. 2 divided by 3. I know that 3 cannot go into 2, but it can go into 20. 6 times. 6 times 3 is 18. 2 left over. 3 goes into 26 times for 18. And sometimes you can see that pattern happening right away. So we see that that is going to be the 6/10 repeating. Or you could write 66/100 repeating. Those are equivalent. Okay, now for the more seemingly simpler part. Now is when we're looking at changing our decimals, given a decimal, to an equivalent fraction. So if it's a mixed number, the whole number stands alone. Otherwise, the numerator is the entire digit after the decimal, and then it's just to the place in which it ends. So again, we're looking at writing what we read. So simply here we have 26/100, right? We know that because it ends in that second place. So we'd write that as 26/100. Notice the direction to simplify. Simplify is where that greatest common factor comes into place. We want to divide until we cannot divide by a common factor again. So here I see they're both even. I'm going to divide them both by 2, not just 1. And then I get 13/50. 13 is prime, so I know that that is simplified. 26/100 is equivalent to 13/50. So again, writing what I read. This is read as 1/10. That's in the tenths place. So that means I have 1/10. That's simplified because 1 cannot be divided any further. Here I have 4 and 7/100. So again, I have a whole number, 4 and 7 per 100. 4 and 7/100. Last one, feel like if you want to try it. 2 and 125 thousandths. So I write 2 and 125 per 1,000. Notice again, though, simplifying. This one ends in a 5, this ends in a 0, so I know they're both divisible by 5 maybe to start. Might not be their greatest common factor, but it is a factor. So that is 2, and I know 5 times 25 is 125 over 200. I see again that they are both divisible by 25. So then I can simplify again, 2 and 1/8. So 2 and 125 thousandths is equivalent to 2 and 1/8. Same number, different representation. Nothing new to write here unless you just want to screenshot this or have these in your notes, the step-by-step for what do I do if I want to change a fraction to a decimal, either method. And then what do I do if I want to change a decimal to a fraction? All right, 6th graders, I hope you can look back at your notes and make sure that they make sense to you. They are supposed to be a helpful resource. Check for understanding by explaining this to a friend, rewatching any section of the video you need to. There's a lot of sections, so you can kind of figure out what I need. And see you soon.